We know that a computer stores data, but how much do we know about how computers actually store it? This video will introduce you to the basic concept of the units used to measure data capacity and exactly how we can use these units for practical purposes. The unit of measurement that underpins all data storage is the bit. However, considering there are an estimated 2 billion computers in the world and each user has a lot of data, the numbers we would be using to calculate capacity and storage would be out of this world. We therefore do something that is very similar as to the way that we use kilograms instead of grams. We start off with the simple bit. Then we have a nibble, which is 4 bits. This isn't used very widely, but it's important for a couple of topics that we will cover. When we have 8 bits, we call this a byte. When we have 1,000 bytes, we call this a kilobyte. 1,000 kilobytes then make a megabyte, and 1,000 megabytes then make a terabyte, and finally 1,000 terabytes make a petabyte. In terms of a home or work computer, you're only likely to see capacities and sizes expressed in terabytes or lower. For example, your storage capacity is likely to be expressed in gigabytes or terabytes, and your RAM is likely to be expressed in gigabytes. When looking at data storage, you will see that the units of measurement are expressed as their abbreviations. Bits simply stay as bit, as does nibble stay as nibble. Byte is expressed as a capital B. Kilobyte is expressed as KB, megabyte is expressed as MB, terabyte is expressed as TB, and petabyte is expressed as, you guessed it, PB. A computer can't simply communicate and calculate like us. They use binary. But why? Circuits within the processor of a computer are made up of little switches called transistors, and these will be one of two states: high voltage, which is shown as 1, and low voltage, which is shown as 0. This is reflected in the 1 or 0 state of a binary digit. We will talk about binary further in the next few videos. An important thing to make sure before saving heaps of work to your laptop or saving some beloved photos is that you actually have the capacity to save your files. For example, say you want to put some songs onto an old first generation iPod Shuffle, which had a lowest capacity of 512 megabytes. A song tends to be, on average, around 4 megabytes in size. You have 150 songs that you wish to save onto this little old device. Will you have enough space? You can work out the total capacity required for a group of files by summing the sizes for all of them. In this case, all of our files are the same size, therefore we can multiply the number of files by the size of a single file. This would be 4 megabytes times 150, and this brings us to a grand total of 600 megabytes. We then compare this to the capacity of our device, which is 512 megabytes. As you can see, our capacity is smaller than the amount of data we wish to save by 88 megabytes. We can't fit all of our songs on the device, therefore we'll either need a new iPod with a larger capacity, or we'll have to make some tough decisions about our favourite songs. We're lucky in this day and age, as computers like to do this bit for us, and that is calculating the size of files. Each type of file has different components, each contributing to the size of the file in their own way. There are 3 formulas you need to know for your exam. Let's start with calculating the size of a sound file. The formula for this calculation is sound file size equals sample rate in hertz multiplied by the duration of the sound in seconds and bit depth in bits. So here's an example. Let's say we have a sample rate of 44.1 kilohertz, which is 44,100 hertz. This is the sample rate of a standard CD. We then have a duration of 1 minute 45, which is 105 seconds. We have a bit depth of 16 bits. So what we do, we take the sample rate of 44,100 hertz, multiply that by 105 seconds, and multiply that by a bit depth of 16. We do all that, and that comes to 74,088,000 bits. Now, obviously, as I said at the beginning, we don't usually use bits to show the size of files. So therefore, if we divide this by 1,000, we can get our total into kilobytes, which is 74,088 kilobytes. But that's still quite a high number. So we can divide this by 1,000 again to get a total of 74.09 megabytes. That's an approximate rounded figure. The next formula you need to know about is for calculating the size of an image file. The formula for this is image file size equals color depth in bits per pixel multiplied by the image height in pixels multiplied by the image width, also in pixels. We'll talk more about color depth later on in another video, but for now you just need to know how this equation works. So here's the example. We have a color depth of 2 bits per pixel, so we use 2 bits to store each pixel within the file. The image height is literally the height of the image. So we've got 720 pixels, and the width again is literally just the width of the image, 1280 pixels. This is standard 720p dimensions. So what do? We pop them into our formula. So we have color depth, so our color depth is 2, times that by 720, which is the height, and we times that by 1280, which is the width. Take that, put it into a calculator, and we get a size of 1,843,200 bits. Once again, this is a massive number, and we don't want to be dealing with that. So we can divide that by 1,000 to give us 1,843.2 kilobytes. But again, we can take this down even more, divided by 1,000 again, and that gives us 1.84 megabytes, rounded approximately to 2 decimal places. Final formula that you need to know for your exam is for calculating the size of a text file. The formula is text file size equals bits per character multiplied by number of characters. So this is the most self-explanatory one. Bits per character, the number of bits used to store each character in the file, and number of characters, the literal number of characters that are in the file. So for example, if your file literally had the word hello, it would be 5 characters. So here's the example. Bits per character, 8 bits. We use 8 bits to store each character. Number of characters, just plucked out of the air, 56,897. This could be some code, it could be a monologue, it could be anything like that. So, we have a look at this then. We take our bits per character, 8. We multiply that by 56,897. Take all of that, pop it into our calculator, and we get a size of 455,176 bits. Smaller number than we've seen recently. Text files are one of the smallest files. We are going to divide this by 1,000, however, as 455,176 is still quite a large number. We can get that down to 455.18 kilobytes. We could go down to megabytes, but we'd be getting into 0.045 whatever, so we just keep it at 455.18 kilobytes. This is usually what a file size for a text file is expressed in anyway. That concludes our coverage of the units topic. I hope you find this video useful, and of course you can always look back on it and comment down below with any questions, or even email with any questions. So if you do have any questions on anything covered in this video, please feel free to comment down below and I will get back to you as soon as possible. Don't hesitate to ask your computer science teacher about anything you don't understand, as they will be the most reliable source of information. Thank you.